Hello and welcome. This video is a continuation of my video series on embedded C. In this video, we are going to explore the repetition construct. Embedded C support the following repetition construct: while, do while, and for. Now, before I go any further, let me define what is a loop. A loop may be defined as a piece of code that can be executed several times in the main function or a main program. There are several techniques in achieving this in C. Okay, let's take a look at the while construct. So here we have the flow chart for the while construct, and on this side we have the pseudo code for the while construct. So let's go back to the flow chart. Here we have the condition. If the condition is true, then the statements will be executed. If it's false, if the condition is false, then it will exit and nothing will be done. So if we compare this condition here and the pseudo code here, here is an example of a condition. Here the condition is set as if B is less than 4. If this is true, then this group of statements here corresponding to the flow chart here, these statements will be executed if the condition is true. If it's false, then nothing will done and the program will exit. So let's take a look at the code here. This is the code that I've chosen for my demonstration. So as usual, I'm starting with the include directive to tell the compiler to include this header file when compiling the program. So here is a void main. Quick reminder, all program must have a main function. And I start off with initializing a variable. So I've set up a variable called count and of the type integer int. And then I set the initial value to 0. So assign 0 to count. So at this point, count will have a value of 0. And we come to the while construct. So the condition is while the count is less than or equal to 6, then we execute these two statements here. And basically the statement very quickly assign count to P0. This is port 0. So in other words, we send the value of count to the port 0. And then having done that, we will increment the value of count by 1 by executing this statement, count equals count plus 1. That will add 1 to the previous value. And once this is complete, when this condition is false, it will exit. So let's take a look at the demonstration. Okay, so we are back in the Kyle IDE. Right, so let's check this thing out. Yeah, let's do a clean targets. Rebuild all targets. Yes, 0 errors, 0 warnings. So debug, start, stop, debug session, evaluation mode. Click OK. Let me just restart this, shall we? And go to View, Watch Window, Watch 1. The count. Let me just remove it. I'll show you, remind you how to do this. So we have, you double click on this here and then type in count and enter. So we'll set up the watch to keep an eye on the count variable. Now go to debug, go to peripherals, IO ports, click parallel port 0 because we're using P0 here. Alright, so we're good to go now. Let's see. So first instruction is to assign 0 to the to count, so we should see a 0. It's already 0, so yes. Now the condition is count less than 6 or equal to 6, so first thing is to output the value of count to P0, so that we should see everything off here. Yes, it's cleared. Next thing is to increment the count by 1. So count equals count plus 1. Watch this variable here, count. It should go to 1. Yes, it does. So it goes back now, and this condition is still true. Count less than 6. So it will output that count to P0. At the moment it's 1. So yes, we see binary 1 here. Now count equals count plus 1. So you increment count by 1. So that's 2. Yes. Goes back. This still holds true. Yeah, it's less than 6. So we output that. So we get a binary 2 here. And then we increment count by 1. So that's 3. Goes back here. This still holds true. So it's still less than 6. So output the count to P0. And it's binary 3. Increment count by 1. So count equals count plus 1. That's 4. So go back, output that to P0. And then increment count by 1. Count equals count plus 1. We should see a 5 here. Yes, it's a 5. Go back. This condition is still true. It's less than 6. Count is less than 6. Output that to P0, to the binary 5. Now count now will be incremented by 1 again. So that's 6. Yes. And this condition is still true. It's less than 6 equals 6. So yes, it goes back and display that onto P0, which it does. So it's binary 6. Now watch this count now. So incremented by 1 is 7. So now this condition is not true, it's false now. So it should come out of the loop. It does, and it ends here. Okay, so we will look at the do-while construct, and here's the flow chart for the do-while construct. So we have statements, and we then go test the condition, and if the condition is true, then we go repeat this, and then we check the conditions again, and if it's false, it will exit. And that's it. So let's look at the pseudo code. So we have example here, statement 1, statement 2, statement 3, and if the condition here, which is b less than 4, if that is true, then this will be repeated. But if it's false, it will exit the loop. Now the thing is to notice that these statements will be executed once, and then the condition will be tested. We now look at the demonstration code. Here we have the include of the header file, and we have the void main. Again, I have a variable called count and of the type integer int. I initialize it by ascribing or assigning 0 to the variable count. Then we move down here where we do, so we set off by outputting the value of count to P0 or port 0, and then increment the count by 1 by performing count equals count plus 1. And then we test for the condition, is count less than or equal 6? If that is true, then we repeat this. If this is false, it will exit and nothing else will be done. Right, now let's look at the do while demonstration. So I've got my project up here, my source code is here. So let's do build target, 0 error, 0 warnings. That's good. So go to debug, start stop debug session, evaluation mode, okay. Right, this time I have the watch already set up here, and I've got P0 here, so we're good to go. So first instruction, assign 0 to count. So you see a 0 here, it's already 0, so we won't see much. Now we'll enter into the loop. So the first thing is it will output that count, value of count to P0, which is 0, so we won't see anything here. It's blank. And increment count by 1. So yeah, so it count equals count plus 1. Yes, it's 1, and check for the condition. Count less than equal to 6. It's still true, so output that count to the P0, and you got a binary 1. Increment count by 1, so that's 2 now. This condition is still true, so go back, output that binary 2 out, increment count again by 1, so count equals count plus 1, so that would be 3. This condition is still true, less than 6. Output that is 3, binary 3, increment the count by 1 is 4. This condition is still true, so it goes back. Output that, increment count by 1 is 5 this time. This condition is still true, less than 6. Goes back, output that, that's a 5, binary 5. Increment count by 1, so count equals count plus 1, so that's 6. This condition is still true because it's equals to 6. Output that to P0 and binary 6. Increment count by 1 is 7 this time, so this condition will fail or it's false, so it should come out of the loop. It does, and that basically ends the demonstration. Okay, so before we go any further, let's briefly compare the while construct with a do while construct. If we look at the while construct, at the beginning the condition is tested. Now if the condition is false, then the program will exit, and this statements will not be executed at all. So there is a possibility that these statements may not ever be executed if the condition at the beginning is tested false. Now if we look at the do while, the statements to be repeated will be executed at least once, because these statements will be executed prior to the condition being tested. So that's the difference between the while and the do while. Okay, so let's take a look at the for construct. And here is the flow chart for the for construct. We start off with the condition. If the condition is true, then we execute the statement or statements here, and then it will come out and increment a counter, and then go back to the condition, test the condition again. If it's true, then we go around this loop. But if the condition is false, it will exit the loop. Let's take a look at the C code format. So this is the format for the C code. So we have a for, we then have an initialization, we have the condition, and then we have a thing called increment here. And the statements to be repeated, or statements is included in within these two curly brackets. So let's take a look at the actual piece of code. I'm going to start off with include directive to tell the compiler to include the contents of this header file. Then the first thing is to have the main function. Next thing is set up a count variable. So this is a variable, and I give it a type integer, int. Here we have the for. I set up the initialization. Here use the variable and set it to 0, count equals 0. So that is the initialize the count. Then the next thing is to set up the condition, and the condition in this case is if the count less than 6, we will repeat this statement here. Having tested for the condition, we then increment the count by 1. So it's count equals count plus 1. This will be this one here. So that would increase the count by 1. And that's it basically. And and we can use this notation for count equal count plus 1. That is count plus plus is this is exactly the same as count equals count plus 1. So that would be it. So let's go over to the demonstration. Okay, so this is the for loop demonstration. Let me just go to build all target files, 0 error, 0 warning. Go to debug, start, stop, evaluation mode, click OK. I've already got the watch window set up. My port 0 is here. So we're good to go. So now for this first line of code, we're going to see count equals 0. It's already 0, so we won't see much here. Then we check for the condition, count less than 6 equals 6. If that's true, it will then repeat this statement, and then increment count equals count plus 1. So let's give it a go. So first one, single step. Yes, count is 0 at the moment. So output that to port 0. That's clear. Now it will increment count by 1. It does. And then this condition is still true, less than 6. Output that. That's a 1. Increment count by 1. That's 2 now. So output that 2. A binary 2 here. Increment count equals count plus 1. So that's 3. Output that. Increment count by 1. So that's 4. So now it would then output P to P0. Increment count by is 5. Output that. Increment count by 1. 6. This condition is still true because it says less than 6 equals 6. So let's output that. And then this should increment count by 1, which would be 7. And ends because this condition is no more true. Alright, okay, that's the end of that demonstration. Okay, before I end this particular video, let me look at something called a nested loops. So what are nested loops? So nested loops are loops placed within another loop. Typically, nested loops consist of an outer loop with one or more inner loops. Now, if you think this is confusing, not to worry, I'll come up with an example in a few moments. Each time the outer loop is repeated, the inner loop is re-entered or repeated. So let's take a look at the flowchart for a nested loop. And if you recognize this part here, this is the for construct. As we have done earlier part of the video. So this is the for construct. So this is a for loop, and this part here is also a for loop, and this is known as the outer loop. All right, the one that is shaded in gray is the inner loop. So this is what we call a loop within a loop. All right, so let's find an application for this. So here's the code it's a C code to illustrate the nested loop. So I have a for construct here, and I have a variable called count1 equals 1, and the condition is if count1 less than 5, we repeat this part here. We'll come to this is another loop, and then we do an increment on the count. So it's count equals count plus 1, and if the condition is true, it will do this part. Now if you look at this part, this is another for loop, so this is another loop. So here I have a count equals count2 equals 1, set the condition count2 less than 5, and then increment count2 by 1, and then repeat this until this is false, and then this comes out, but it will re-enter this loop again if this condition still holds. All right, so the outer loop would end when this condition is met, but until then it will repeat this part several times until this condition is false. Okay, let's take a look at a practical example of this nested loop. Okay, so let's take a look at the loop within the loop demonstration. So here I set up two variables, count1 and count2, set them to the type integer, int, and then this is the outer loop, and this is the inner loop. So let's go to clean targets, rebuild all targets. So we've got 0 errors, 0 warnings, debug session, start stop debug session, evaluation mode, click OK. I've already set up the watch window with count1 and count2, and I've got port 0 and port 1 up, so I think we're good to go. So first line code, initialize count1 to a 1, so we should see a 1 here, and then check for the condition less than 3. If it's less than 3, then this inner loop will be executed. So let's go ahead and do this first. So watch count1 is set to a 1, and this condition is true. So now we're entering into this loop. So the first thing in the inner loop is to increment set count2 as 1. So watch count2. That's a 1 now. The condition count2 less than 3 is true, so we will execute this. So that will display the value count2 to P0, which is this one here. Yes, it's done it. It's displayed binary 1. Now this will now increment count2 by 1 using the plus operator, so that we should see a 2 here. And this condition is still true, less than 3, so we output that count to P0. Yes. Now watch count2 now, so it will increment count2 by 1, and that's 3. So this condition is no more true. So it will then go back, re-enter the inner loop, because this condition is still true for the outer loop. So we will now re-enter the inner loop So count 2 will be set to 1 again. Yes, it does. This condition is true now. It's less than 3, so we output this to P0. Yeah. Increment count 2 by 1, so it's 2, so it goes back, and then output this value to P0. Yes. Now increment count 2 by 1. So this condition now fails because it's should be less than 3. Now the outer loop at the moment is 2, but when we execute this, count 1 by 1 is 3. So this condition is also false now. So this whole thing is done. It should exit, and it does. So the 2 loops is now complete. Okay, so that's it for this video. The source code that I've used for this video is given in the link below. And thank you for watching. See you in the next video. Bye.